Hello, my name is Donald Akbaş. We are going to present you fracture detection with tomosynthesis images. Our group number is 34.
Hello, my name is Buğra Altan. Within the scope of this study, the aim is to develop the most compatible model for performing fracture detection in X-ray images. We have no doubt that this project will be used frequently, especially in the emergency departments of hospitals. With this project, a great convenience will be provided in the lives of the patients who have adequate equipment or who wants to get results quickly. Let's talk about what we need. We created a path to develop this project. First, we find a dataset which includes X-ray images. Then we have to train the dataset with YOLO V7, which is obtained as the best real-time object detectors. We use Python to use the pre-trained model and PySide 6 and Qt for the app interface. And engineering requirements. Our program cuts the human error as a result of doctors in hospitals. Program being easily accessible program. Software update is available via internet, suitable for the use of Windows 7 and above operating systems. Marketing requirements. Our program quickly detects the fracture of bones. Patients benefits from this project without wasting time. Software program is used all around the world. The users have an opportunity to check if the program is up to date. And it is open source, then all users are able to reach the program. Let's check our design steps. We found the dataset, which name is Grasspike Ray, and dataset has 20,327 images and their annotations. Then we use YOLO V7 to train the model. We will detect 9 different things which you can see on the screen now. They are type of bones illness. Then we use the pre-trained model in our Python script. And finally, we created our app interface with necessary libraries. And you can see that the flowchart of our final design project. We explained the steps in the last page.
The next step we are going to talk about is how we implement the project. First, we train our model with our dataset. We aim to use YOLO V7. We create a conda environment, as you can see on the terminal screen picture. Then we change our base environment to YOLO V7 underscore custom. Another library we use is PyTorch, which is an open source machine learning framework. There is a training command, which is the last step for our training process. When we run to script, which is the bottom of the page, we get a running line, which is the matching the images and their labels, which shows us the accuracy of how many of our X-ray images are matched with their annotations. When the training process is done, YOLO V7 environment creates us .onyx file. It allows us to export training models from one framework to another. We use that .onyx file inside our script. To make a summary, the code takes an input image, applies object detection using pre-trained model, and generates an annotate image with bounding box with around the detect objects. It also saves the annotation information for further analysis or evaluation, which is so important to develop this project lately. We imported necessary libraries which are OS, CV2, NumPy, and PySide 6 Qt widgets. And there is the object-oriented programming part for our project, which is so helpful to make a clear and readable code. We created a class whose name is main window. We have 6 buttons in our project. They are Open Image, Predict, Save, Clear, Quit, and About Us buttons. It's clear that we can understand what they do from function name. And this is how the final app interface is looking. You can see the buttons which we have explained before about their working methods and the cover page. First of all, we would like to show a table that talks about difference of YOLO V7 with other real-time object detectors. YOLO V7 is 120% faster than others. That's why we choose the YOLO V7. After training finish, we also got some curves which are F1 and PR. The F1 curves likely refers to F1 score, which is measure of model's accuracy in object detection task. A high F1 score indicates a good balance between precision and recall. The PR curve likely refers to precision recall curve, which is a graph that shows the relationship between precision and recall. As you will see now, we can test our program. After problems we solved using certain debuggers, our program is running with fast and precise results. At the same time, the use of the buttons is smooth as we want. We can expand or reduce to interface of our application as we wish. At the same time, you can directly access our LinkedIn accounts. The image we have present as a proof of this. The image shows that how the predict button works clearly, and we can also prove that our model learned from the learning process from dataset. We can save the predict image and its annotation. If we click the button, About Us button, we can go to our LinkedIn profiles directly.
Our project doesn't require us to purchase any software products. Fixing the bugs doesn't cause us any financial problems. In our project, there are two things to cost. While training our model, we consumed electricity, and the second one is we calculated how much software engineers earned approximately per line of code they wrote. It will be calculated as $5 per line of code, and we wrote a total of 507 lines of code. In order to interpret this project in commercial dimensions, we need to consider where and to whom the project is addressed. Our project doesn't require a doctor's examination in order to quickly get results. We can help patients by providing fast and accurate results in return for this work. We know how many people waiting in line in the hospitals. If we can brand this situation and advertise it more, it will provide us with a great return. If we can get the project out to people with certain trial versions, and people will be excited to buy the full version of the project when they see how accurate the project is and save their times. Our project works in harmony with three licenses and certificates. First of all, GNU General Public License and CE certification and ISO IS 12207. And thanks to these standards, the security of the program and the data security that we know to the users are essential. We can easily tell the users that the program working with these standards can use them safely with their data and without accessing their self-documents. Files of the program have passed the necessary virus tests and do not contain any harmful code. Thanks for listening us.
Thanks for listening.